This is a review for PC number 2, solving systems by elimination. The 4 things we learned this week were scaling equations, which means to manipulate them by multiplying or dividing. It changes each term in an equation. Secondly, adding equations by columns. And in some cases we subtracted. How to do that? Then, solving for a variable using elimination. If we are ever faced with an equation that has 2 variables, it's impossible to solve. So we have to eliminate at least one of them. Then, plugging back in to find the other variable. Because to solve systems by elimination correctly, you need to solve for both x and y. Please follow along with your review, and you can use this paper as notes for your assessment. First up, we are scaling this equation. The equation reads 3x minus 10y equals 0, and we are multiplying the entire thing by negative 3, which works kind of like distributing. That means we are multiplying each term by a negative 3. So if you were using a calculator, you would do 3 times negative 3 to get negative 9. Don't forget the x. Negative 10 times negative 3 is a positive 30. Don't forget the y. And anything times 0 is going to be 0. Pay extra close attention to the negatives. When you multiply 2 of them, remember it comes out positive. This same trick works in reverse, dividing instead of multiplying. So here I take each term and I divide by 4. We are dividing all 3 terms by 4. So here on the left, 12 divided by 4 gives us 3, and the variable comes down. Remember that we're not just looking at 16 divided by 4, but the negative goes with this term. So that's why our answer is minus 4, and then the y comes down. And finally, this is all equal to a negative 7, because negative 28 divided by positive 4 is negative 7. The next skill we are using is adding columns straight down for 2 equations. So notice the x terms line up, the y terms line up, and the constants line up here on the right, because both of these equations are in standard form. You might remember that from last week. Here we are adding, so that simply means we add the coefficients straight down. 5 plus a negative 3 gives us 2. Negative 10 plus a negative 6, if you put in your calculator, it brings it further negative, all the way to negative 16. And finally, 15 plus 1 is 16. For this next problem, subtraction can be a little more confusing. What I would recommend is to change every single sign. Instead of subtracting, we're going to add. But that means all of the negatives become pluses, and all of the positive values, like 8, become negatives. Then when we add straight down, negative 4x plus 4x, the x's are eliminated, because 0x is the same thing as 0. Negative 1y plus y, the y's are also eliminated. And finally, 8 minus 8 is 0. This is a special case, it's a true statement. But that is how you can subtract. You change all the signs, and then you add. So if you're still with me, all we practiced so far were the skills. None of the problems in the test will look like what you've done so far. This, however, will show up on the test, or a problem very much like it. And the key thing to look for are the coefficients for x and y. And remember, the coefficients include the signs in front of them. So for x, we see different numbers, 2 and 4. If we were to add these together, we would get 6x, which doesn't eliminate anything. However, if we add together negative 3 plus 3, the y coefficients, we get 0, which means we eliminate y. And what this allows us to do is we can add all the columns straight down, and we are down to 1 variable, which means this is solvable. So what we are looking for is coefficients that match 3 and 3, 1 being positive and 1 being negative. And when we do so, that variable is eliminated. It's canceled. It's gone. 0y is 0, so there's no need to even write it. Finally, to solve for x, we divide both sides by 6. and we have half of our answer. What this means is that x equals 6 is true for both of these equations. So we're going to pick one of them. Doesn't matter which. I will choose the second one. And instead of writing it as 4x plus 3y is equal to 24, I'm going to replace x with what it's equal to, which is a 6. So I'm going to multiply 4 times 6, and this gives me 24. Everything else carries down. Where did the 6 come from? Right here, and it plugs in right there. Where did this equation come from? You pick any of the original equations, and you replace the known variable. In this case, we knew what x was. We're down to a two-step equation. Hopefully you remember how to do this from the first semester. You would subtract 24 from both sides. We're left with 3y is equal to 0. And when you divide by 3, we get y is equal to 0. So your final answer would be x equals 6 and y equals 0. So let's look at the last problem on the first page. We can see that our y coefficients are different numbers, 5 and 7. We're not going to eliminate by adding there. If we look at our x coefficients, they're the same. But if I added 6 plus 6, I would get 12x. So then I'm still going to have an x and a y, and it's still impossible to solve. I want to eliminate x. I want to have 0x. So what can I do? The trick is I can multiply this second equation by -1, which is a fancy way of saying I'm going to change the sign for all of the terms. -20 becomes +20, -7y becomes +7y, and 6x becomes -6x. Now, if I look at my x coefficients, I have 6 and -6. So if I add these two together, I get 0x, which means x is eliminated. I don't even need to bother writing it. When I add 5y plus 7y, I get 12y, and 4 plus 20 is equal to 24. Some division, and I find that y is equal to 2. I'm halfway to my answer. The next step is to pick any one of my original two equations. Let's say I chose the first one, and I will rewrite it. But instead of using y, I'm going to use a 2. So 6x plus 5 times 2 is equal to 4. Notice I took the 2 from my original equation, from my original solution, and I replaced y. You multiply 5 times 2 as the first step, so you have 6x plus 10 is equal to 4. And now I'm back to a two-step equation. Subtract 10 from both sides. This gives me 6x equals -6. Divide by 6 on both sides, and I have my final answer, x equals -1. So my solution requires y equals 2 and x equals -1. Let's look at the next problem on the back. As written, if I was to add straight up and down all of these columns, I would get -4 plus a -1 is -5x, -15 plus 5 is -10y, -17 plus a -13 is a -30. The problem is, I still have an x and a y. This is unsolvable. What I want to do is change one of my original two equations so that when I add straight down, one of my variables is gone. It turns out if I take this second equation and I multiply the entire thing by 3, this 5 becomes 15, and -15 plus 15 is gone. It gives me 0. So that's how I determine what to multiply by. I look for multiples. For x, I could have multiplied by a -4 to give me a positive 4x, which would cancel this out. Or for y, I could have multiplied by 3. That seemed easier. So let's multiply each term then. -1x times 3 gives me a -3x. 5y times 3 gives me 15y. And -13 times 3 gives me -39. So I will go ahead and cross this equation out since I have now changed it. And I have a new system of equations. If I add these straight down, what do I get? -4 plus a -3 is a -7x. Negative 15 plus 15 gives me 0y, which is what I wanted. And negative 17 plus a negative 39 is a negative 56. Some simple division here, dividing by a negative 7, will reveal that x is equal to a positive 8. And I'm halfway to my answer. The next step is to choose one of my original equations. Let's say I choose this first one and rewrite it. But instead of x, I'm going to use what x is equal to. So I'm going to bring in the 8. This gives me negative 4 multiplied by 8, which came from here, minus 15y is equal to negative 17. I multiply negative 4 times 8 to give me a negative 32. I rewrite the rest of the problem, and I'm down to a two-step equation. First thing I do is add 32 to both sides. This gives me negative 15y is equal to 15. When I divide both sides by a negative 15, I get y is equal to negative 1. And my final answer is that x is equal to 8 and y is equal to negative 1. Which means if I plug these numbers into either of my original equations, they come out true. One final problem. Which variable should I try to eliminate, x or y? As written, adding straight down will cancel out neither of them. So I have to multiply an equation. What could I multiply 5 by to get 7? Well, nothing. It'd be a decimal. But how about 3? Could I multiply that by something to get 9? I sure could. In fact, I could multiply this top equation by 3. So let's do that for each term. Negative 9x plus 21y is equal to negative 48. And I'll cross off just to keep track of which one I manipulated and which one was the original. There's a problem though. If I add negative 9 plus negative 9, am I going to get 0? They both have a 9, but if I add straight down, will I have canceled out x? And the answer is no. So what can I do about that? The answer is to flip all of these signs. So negative 9x becomes positive 9x. Positive 21y becomes minus 21y. Negative 48 becomes plus 48. And now I can add all of my columns straight down. X is eliminated like I want it to be. Y becomes negative 16. And 48 plus 16 gives me 64. Now when I divide both sides by a negative 16, I get y is equal to negative 4. I'm going to take one of my original equations then. Negative 9 times x plus 5 times negative 4 is equal to 16. Notice my y value came from here. I know that y is equal to negative 4, so I can replace it. And if I rewrite this equation after the multiplication, it's negative 9x minus 20 is equal to 16. And this is your standard two-step equation. Add 20 to both sides. Negative 9x is equal to 36. Divide by a negative 9. X equals negative 4. You know you have the answer when you have solved for both x and y.